So at the beginning of the notes, we covered the derivative of sine and the derivative of cosine. Down here at the bottom, we're going to also look at 4 more that we can just use and plug in terms of substitution. So we have the derivative of tangent is secant squared x. The derivative of secant is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. And the derivative of cotangent x is negative cosecant squared x. I'm also going to set up here while you're copying those down. On the back of the page, we have our trig identities. So these are the ones I just used the cosine x squared x plus sine squared x equals 1. Just in case you forgot them, I do have them written here if you want to jot them down. They may come up. So as I move now to the back, we're going to do example 3. So for example 3, the good news is you're going to be able to use some of these definitions quickly to get through the early steps in the problem. And here's what I mean by that. First of all, take a look. The problem I am asked to find involves f double prime. I'm drawing an arrow because I want to point that out to you. F double prime, in order to get there, you're going to need f prime first. So these are those higher derivatives that we did a lesson on. But now we're going to do higher derivatives involving a trig function, most likely. So I want to find f prime of x first. And I can use what I wrote down here in order to do that. So if I look here, my derivative of secant is secant x times tangent x. So technically I'm done with f prime. I found it. But now I need to do f double prime of x. Okay? F double prime of x is going to be an example of the product rule. And I know that because I've got 2 functions being multiplied together. They just so happen to be trig functions. So my f double prime of x, if it's a product rule, I'm going to set it up for structure. So I'm going to do this right from the beginning, just so I know everything I have to fill in. And remember, product rule is the f function times the derivative of the g function. So the derivative is up here, secant squared x, plus the g function, which is tangent x, times the derivative of secant x, which is secant x tangent x. Now, at this point, we could go and plug everything in, but it's going to help us to use a little bit of algebra to clean this up. So if I take a look at this and this, I've got two different terms. What is my GCF of this? What can I take out from both of those separate expressions? What can I take out of here that's the same as out of here? Secant x. So I can rewrite this as secant x times secant squared x plus tangent squared x. Okay, so I used, in this case, greatest common factor. Now, maybe you feel those little alarm bells going off. Oh, those are squareds. Can I simplify further? Well, let's look. If I come up here, can I rearrange this bubble to say secant squared plus tangent squared? The answer is no. If I move the tangent to the other side, it gives me subtraction, not addition. So I'm not going to be able to use any of these trig identities to help me out. I now have to actually do the problem. F double prime of pi over 4 is equal to the secant of pi over 4 times the secant of pi over 4 squared plus the tangent of pi over 4, that whole thing, squared. All right, so if we go to pi over 4, let's do a quick little drawing here. Pi over 4, it's going to be up here, the 45. I need two things. I need secant, which goes back to cosine. So remember, secant, let me bring this up here. Secant is equal to 1 over cosine, or 1 over x. And I'm also going to need the tangent, and tangent is y over x. Root 2 over 2, root 2 over 2. So 1 over x, 1 over root 2 over 2, if you remember, simplifies down to what? Anybody remember what 1 over root 2 over 2 simplifies to? Root 2. Okay, multiply by the reciprocal, rationalize the denominator, do all of that work. Tangent of y over x is root 2 over 2 divided by root 2 over 2, which is 1. Okay, this was all from prerequisite, all of this. So now I'm going to come back and I'm going to substitute in. The secant at pi over 4 is root 2 times root 2 squared plus 1. Root 2 times 3 is 3 root 2. And I'm done.